Devanjan Mishra. He is a senior data scientist in Mercedes-Benz research and development team, and he has vast knowledge in computer vision and AI and deep learning. So I welcome Devanjan, and now it's over to you.
Thank you, sir. So I'm Devanjan, currently working as senior data scientist at Mercedes-Benz India currently. And today I will be sharing a few insights related to my learnings in industry around Gen AI applications and the usage of Gen AI and the deployment part of Gen AI applications with everyone. So should I get started? Hmm? Okay. Okay. Yeah. Let me share my screen. Let me know when you can see my screen. Okay. So this will be our agenda for today. So today we'll start the discussion around the deployment requirements for Gen AI applications. Why I am coming to the deployment requirement first is primarily because developing a Gen AI application is very different from actual production level Gen AI applications. So you can develop anything locally, and it may or may not be possible to productionize the application. So my current focus for all the industry level engineers or for engineers who are going to be in industry soon is primarily to ensure that I am able to give the knowledge around the deployment part, because that is where most of the most of the engineers are still in the dark. So that will be our first point of discussion. Second will be around a framework which I have selected for GenAI, Olama. I mean, it is my personal choice, but anyone can have their own choice and go ahead with this. So today we'll go with framework of Olama, and then third will be industrial applications of this framework that we have currently used for our use cases. So that will be the third point of discussion. I would encourage everyone to ask questions. If you have any doubt, just stop me, ask question. We can have a discussion and we can go ahead from there. Okay. So first point, deployment requirements for GenAI applications. So in this, we'll be talking about Docker and Compose deployment and API development. So you may or may not be aware that almost all the services or all the development or deployment of production grade software nowadays is done through Docker. So if you are a software development engineer or planning to be one, Docker and Compose or API and API is must. You can for API you can select whichever language you want to. I personally use Python, Flask, Fast APIs, but it's entirely up to you. But Docker and Docker Compose basically has become a bread and butter for any deployment that we now see on industry level. You must have heard about architectures like microservices or monolithic. Almost everything now is done through Docker and scaled up or scaled down with Kubernetes built on top of Docker. So Docker or Compose, Docker Compose is the bread and butter for today's software engineers. And API is the basically the gateway or the I should say pathway for different Dockers or different Docker containers basically to talk to each other. So that's why API is also important. And as a unit, they basically become the backbone of any production level code deployment across industries today in the current modern age. So if anything, if anyone wants to learn anything from this, I would request, I would highly encourage, this should be the first thing that you guys should be looking into or putting it in your build. Okay, so quick introduction around Docker. I mean, I've not gone really into deep. I would encourage everyone to look into deep into Docker containerization and Docker Compose. I will also share uh, few guidelines around how we basically learn the Docker, and you guys can follow that. But Docker is basically a containerization platform that allows developer to basically package programs into containers. So containers basically become your is it, sorry, yeah, container basically become your completely isolated entity which runs on its own. It has its own host OS which it uses, and it has its own dependency, and it doesn't interact with your OS on your system or on the web or AWS or anywhere else wherever you deploy the Docker. So the major application of Docker comes from this because it takes care of the dependencies of applications. So for example, if locally you are running something, let's say with Python 3.12, and if you pass on your application for someone else to test it, and if you have not built a Docker and if you just provide the source code along with the, let's say, the requirement.txt file, and ask someone else to do it, he may have a Python 3.11 in his system, or he may have Python 3.9 or some different OS on his system, and the application will may or may not behave the same way as it was behaving in your system. So that's why nowadays Docker has become a standard way of sharing applications across, because it takes care of the all the dependencies built on top of OS. So that's why it lets you run your operating system as a container, and that is very important going forward, because GenAI, especially around GenAI, you have a lot many dependencies which uses hardware acceleration, also like CUDA, or which uses base software layers. I mean, CUDA in itself has lot many architectural layers. It has hardware acceleration. It has software layers, abstractions, which if you have not provided the Docker to it, it it has a possibility, it has a probability of may or may not be running on someone else's system. So in total, this is why Docker is very important today. Uh, so I've quickly given the reason around this. The other two important parts, I think it helps you do the deployment very quickly. So you can destroy a container and repackage a container or remake a container within seconds, which generally doesn't happen if you are doing it from your system. So if example you are building a virtual environment, again it might take a lot of time, but that generally doesn't happen with Docker. Security wise, it's very important, especially if you consider cyber security on a production level or on a or actually on a company level things. So it is very important that you use Docker, because it allows complete control over the traffic flow. So whatever traffic is coming to your application can be managed very easily by Docker. And the last part, I think this is the most critical one, which is scalability. So Docker is not used in itself, but most of the times it is linked or it is mapped, and Kubernetes is mapped on top of it. And Kubernetes basically takes care of auto loading. So if there are more number of users for your applications, Kubernetes will start more container having your same application across. So it can do a horizontal scaling across multiple containers. If there are more number of users, let's say it's an Amazon sale today, um, there will be more number of customers hitting the Amazon website or Amazon app. So Kubernetes, what will it do is it will increase the number of containers which are available for the Amazon application or the landing page of Amazon. And when you have your regular days, the number of consumers hitting the website is not huge, then it will scale it back down so that you don't use resources which are not really required, and you optimize on the spending of those resources or those compute. These are basic Docker commands. Docker, I think this is something which everyone should know. Docker build, Docker version, Docker run, which containers are currently running on your system, how to stop a container, how to kill a container, how to pull images. So Docker repository or Docker Hub is one where you have open source images, but most of the companies have their own Docker Hubs, artifactories from where you can pull the specific company-based Docker images also. Then you have Docker push. Again, just like pull, it you basically push your image into the Docker Hub, and then RMI is basically to delete a image. So image is what we build using Dockerfile, and when you deploy the image, it becomes a container, and that container is a self-contained application of your software. And Docker RM container ID, which basically deletes your container or delete a stop container basically. I will share a roadmap of how to learn a Docker. I have a word file with you. I will share it with everyone so that you can go through. We start with very basic examples: Alpine image, Alpine Python image, or Alpine Ubuntu image, which is very small, and you can deploy it with maybe 60 or 70 MB of space. And if you are working on, I would suggest if you are working on your local systems, most of you will be having Windows. So I would suggest everyone to have a Docker desktop version up and running in your system. And if you have Docker desktop, then let's say tomorrow you want to try a GitHub repo which works with only Ubuntu or which has all the Ubuntu dependencies. Then you can use Docker and base image of a Ubuntu system or a base Ubuntu image. We have multiple images depending upon the OS requirements that are attached with those Ubuntu images. They can be as small as Alpine, which is 70 or 80 MB currently, and it can go all the way up to 1.2 GBs of Ubuntu systems or Ubuntu images as well, depending upon what you actually want to keep. The general idea is always to keep the images as light as possible so they deploy quicker, and if I want to start a new container, I can do it much quicker. So I would suggest everyone to at least have Docker desktop in your system. If it is Windows, if it is Ubuntu, it's very fast to install Docker. And then if you want to try out a repo which was only possible with GitHub, which was only possible with Ubuntu, then you can use Docker to get around it. Coming to APIs, as I mentioned, APIs are basically gateways or a set of tools to expose endpoints between Docker. So I told that Docker basically containerizes everything as one small entity, right? Now, how do you talk to this entity is via API and host ports. So you expose a few ports on your Docker with which um, anyone from outside environment can talk to the Docker container, and you can manage that talking. You can actually look from where the traffic is coming with these ports, and the way you talk with these containers is via an API. So you can share a payload, let's say a JSON file, via this API to the container using ports, or you can also consume the APIs. So for example, if there's an external API and you want to use this external API and send some data inside, then also APIs comes into picture. And if you have some data which the Docker is generating or which your application is generating, and you want to send it out to the outside world, there also you use API to do this task. So um, in all, generally, there are many other methods in APIs apart from the basic ones, but I will not cover those. Those are not currently really very important for everyone. But the basic ideas of pushing uh, uh, these API app routes is what currently we will be looking into. Okay, so this is, I think I have already covered, but basically why we need the containers, why we need APIs. This is a basic example. So Kubernetes sits on top of containers and APIs, and Kubernetes allows or basically controls the number of containers that should run for a given application based on load, traffic, and many other circumstances. Let's say one of the containers has died down due to X number of reasons, then Kubernetes will spin up another container, and till the time it's not healthy, it will not shift the traffic to container B. So all of this can be taken care by Kubernetes. Kubernetes is slightly more advanced topic, so you can take that up also, but I would suggest at least take up Docker, understand Docker. Kubernetes, you generally have separate engineers in most of the teams who take care of Kubernetes and the loading or the traffic management of containers. Uh, yeah. So this is a quick example. If you have a Python application running in container A, you expose it via an API to some port, and container B can accept data or any other thing from container A via these APIs. And Kubernetes basically looks around and see if both the containers are healthy and working fine or not, and if they need to be scaled or not, or scaled up or scaled down. So this is all about APIs. Now coming to framework discussion around Olama, but before that, I would ask if anyone has any doubts till this point, because this is very critical. We'll be taking the one of the examples using APIs, containers, and GenAI applications. So if anyone has any question around this, please let me know.
Yes, there is a question in chat. I think difference between Docker and virtual machine.
Okay. Yeah, so virtual machines. Um, is this up right? So, so virtual machines, what basically happens in virtual machines is you have this hypervisor also there. Hypervisor basically takes care of the OS dependencies and implementing those OS dependencies. And then on top of that, only your OS will come and sit. So you have more number of layers before you actually reach your application. So your application is sitting somewhere here, but before that you have to have hypervisor and then an OS built on top of it. What Docker provides you is it uses the host OS itself. So let's say currently it is Windows, right? Windows will have a different sort of Docker engine, which is basically your Docker desktop. And if it is Ubuntu, it will have a different Docker engine, and your application can sit right on top of this Docker engine. So how you build a Docker engine basically changes between OS, but that is taken care by hypervisor here. So hypervisor basically installs a specific OS version on top of it, and then you have the your applications and dependencies sitting on top of it. So it is more complicated in terms of execution, scalability also, because it takes a lot of time to scale up all these things. You have to have a guest OS built, then you build your applications. You have to have hypervisor also built. So building a virtual machine takes time, and it is not easy to scale it up or scale it down. That's why we generally go around with Docker. But other than that, virtual machines, they offer you better control, or let's say it provides you with UI, right? So usability wise, virtual machines are better, but in actual production, you will always go with Docker. Did I answer the question?
Yes, I think there are some other questions in the chat.
Oh, okay. Let me see the chat. Once again, sir. This metaverse will be a part of OS. Yes, OS. It depends. Are you talking about guest OS or host OS? So Docker requires a base level of OS. So you can build Ubuntu on top of it, or different versions like Debian and any other. Based on your requirement, you can build on top of that. Even Ubuntu has different version, LTS version 21.04, 22.04, and all those. So uh, Docker actually requires a guest OS built on top of it. Docker is used for ML training as well. Yes. So Docker, basically, training wise, let's say if you are using CUDA for your GPU acceleration, CUDA basically offers you a quicker training around turnaround. I will not go into the details, but basically it helps you with the matrix multiplication and everything, right? So if you must have seen, if you have trained any ML model, if you use CUDA, your training time reduces drastically, right? So CUDA is generally preferred to be built on top of Ubuntu OS. So generally, what people do is build a Docker image, and then they enter the Docker image, make a container, enter the container, and then do the training inside the container, and then ship out the or attach a directory to the container, and store their trained weights in that container, in that attached volume. So when you kill the container, the attached volume still has the learned weights available. So yes, Docker actually helps you with training ML models also, and definitely with the deployment of those models also. Uh, any other question? Hypervisor. I have not really used hypervisor a lot, but it basically deals around with installing a guest OS on top of your existing OS layer. So you cannot right away install a new OS on an existing OS system. So let's say currently we have Windows. I cannot right away install uh, Ubuntu on top of this. What can we do easily is have a separate um, storage available, or a separate storage available for Ubuntu system, and install it parallelly. But if I want to install another OS on top of existing OS, then it becomes very difficult. And hypervisor is uh, how it takes care of this secondary deployment of a guest OS on top of a existing host OS. I've not really gone into the details of how it does that, but that is the basic idea. If I want to attach a local directory, and if I want to store something in that local directory, I will use volumes to attach a directory inside the container and to the outside world. So that's where volumes comes, and that's how we use volumes. We'll go through that quickly, but yeah, this is the basic idea. I think then we should move along. Uh, okay, yeah. So Olama is my personal choice. You guys can go with your own uh, GenAI framework, LLM framework. Olama is what I prefer because I feel it to be lot easier and more consistent. And the biggest reason is it is completely private. I can run it locally, and it has very good, it has very quick setup, and it is completely private. So if I switch off my internet and then also run this framework with the models, it will run because everything is local and nothing really talks with the outside world. So if I want to keep my data private, which is always the case in industry, then Olama, at least from the development perspective, is a good starting point. Okay, so what is Olama? Olama is a tool to run large language models. I'll not go into the details of the abstraction of how it does it, but basically it's a framework which runs LLMs on top of it. These LLMs are basically built exactly to be run on Olama. So you can run any LLM on Olama. Olama regularly publishes its own models based on the top models that are currently available in the open source market, and then it makes its own version and deploys or keeps those for downloading and using purpose. So let's say DeepSeek is here, Gamma is here, Qwen 3 is here. Qwen 3 is what currently we will be using. It's very, I mean, in terms of coding and in terms of understanding or in terms of language control, I think this is very good. It's at least better than the DeepSeek R115B model. Sorry, the 7B model. I'm using the 5B here. I'm using the 7B model, and I prefer Qwen 3. Why is it so powerful? Again, as I mentioned, it takes care of privacy. There's no cost. That's I think the best part. I don't have to pay just a open AI sort of fee here. Nothing like that. It's great for testing and prototyping. It's generally not used for deployment, but it is changing now. Slowly and surely it is changing. But at least for development or prototyping, if you want to, let's say, benchmark which model works best for my use case, then you can start with Olama and very quickly test across different LLMs, embeddings, and go about it. Yeah, so integration wise, it's very easy also. You can, Olama provides its own APIs for you to talk to it, and you can build your own APIs on top of the existing APIs. We'll see that example as well. Um, and I think I've already covered all these points. Yeah, okay. So I will quickly show how Olama looks like. One second. Yeah. So this is how Olama looks like. If you go to Olama website, you can download the OS, Mac OS version, Linux version, or Windows version. These are the models available here, right? Thinking basically is if you have heard about a few agents which do thinking. So thinking part is where LLM talks to itself and tries to come up, break your question or break your query into multiple smaller steps and execute it one by one. It just like humans, when someone asks us question, we think about it internally, then answer it. So it tries to mimic that, and that's why its reasoning improves. So most of the models now you will see will have at least some thinking attached to it, either as a separate external entity. So when you get the response from the LLM, you will have a thinking part also to it, or sometimes it is done internally and it is not exposed, which happens I think in gamma models. Then you have tools also, so tool calling. So we will take this example also, but this part I think is very it's very powerful for industrial perspective, because uh, I don't want to have text as an output always. Sometimes I want to have a JSON, sometimes I want to have a data frame, a table, right? So LLM in general will always return a text or an image to me. but a text is not always useful. So if I have an application which accepts only two numbers, or which accepts only a number, and if I attach a LLM and if I do all sort of NLP task on top of the output of LLM, we may or may not get the values which are required, right? So tools is something which helps you there. It basically makes your output structured, and the most used structure is JSON. You can use numbers also, and integers also, but mostly what we use is JSON. So these are the basic things around Olama. You can go inside like this, and after installing Olama locally, you can just copy this command and paste it in your CLI, and it will basically download Qwen3 model locally. You can select different versions of uh, Qwen based on your system requirements. Currently, like, I'm using Qwen 3, 5.2 GB, but again, it's entirely up to you and the system requirements that you currently have. Uh, this is some documentation around it, how it performs, how better it is, how much better in different across different benchmarks. I would suggest everyone to go through these LLMs, these models, try and understand how they are so good, why they are so good, and try and make sense out of that. Okay, yeah. So then let's directly jump to the industrial applications. So first one is aspect-based sentiment analysis with feedback, canonical, structured output. So it's a mouthful. We'll cover that. And then the second one is document generation and documentation generation. So and code flow. So basically, if you have a code directory, let's say it is written completely in C++ and you're not aware of C++, or it is completely written in JS, and you have not seen, or you have not ever programmed in JS, and you want to understand um, what the code is all about, or what the code is doing, then you can use these GenAI applications to get the code flow, get the documentation, try and understand. Let's say if you want to build something in C++ based on something which is already available in Python, then this offers you a documentation of how you can do or go around it. Before this, any questions again? Anyone? Okay. Then yeah, then let's jump to the use cases. Okay. So aspect-based sentiment analysis with feedback, canonical, and structured output. Basically, what we are doing is, if I have a text, if I have, let's say, 3 or 4 sentences, and I want to extract it in a form of a standardized JSON. By standardized, I mean the key value pair, the keys are always standardized, but the values are also standardized. So let's say if I'm reviewing a movie, and I want only 4 options in the final JSON output, which is the quality of direction. So it can be very good, good, bad, very bad. I want the output to have only these 4 options available, but I will not provide these value labeling also. So that's what these LLMs can offer. So I will go through these steps, and then we will go to the actual execution. But let's just go through the steps first. So sentiment analysis, I think all of you must be aware or should be aware around this point. Basically, if I want to do a rating, I want to rate a text or a review between 0 to 5. Uh, this is a standard NLP task. I think there are many models available which are already fine-tuned on sentiment analysis, or you can take your own data and fine-tune uh, regular model, NLP model, and go about it. But The reason LLMs shine at this point is basically because LLMs already have a lot of context because they are trained on so much data. So you really need not do a fine tuning of a model. You can directly use an LLM to do a sentiment analysis. The second part is another interesting thing. So let's say if I want to select few important things or few important details out of the text, like slow service, great food, right? The reasons LLMs shine here is because they are built on transformers, and transformers have a attention mechanism, and that attention mechanism is good across a very big text. So if I have written a very long review also with a lot of sarcasm also, most of the times LLM is able to understand the sarcasm and able to grasp the right words out of your text. Let's say even if it is 4 or 5 sentences, it will extract the right words using self-attention. So this is one part of it. I mean, it is known by many names: aspect-based sentiment analysis, opinion mining. So if I want to, uh, let's say in my industry, we have a lot of, we basically ask clinics. So clinics is where we basically ask uh, a blind customer of how he is feeling about certain feature, and that opinion is which is generally a text. It is most of the times text heavy. It has 6 7 sentences, and only if I'm a domain expert, I will be able to extract the right words out of it. So that's why it is called opinion mining. And named entity recognition, I think, again, standard NLP task. The final, the third point, which I think is more critical, and again, this can be done with the NLP, but again, it requires a separate model, it requires a vector embedding and all those things. But basically, the idea is it's able to understand the semantic meaning of different words and whether it means the same thing or not. So, example, slow service and service was slow, both of them are similar. So, instead of building a separate category of slow service and service was slow, I will build only one category. So, this way I will be able to reduce the number of categories I am building. So, uh, if if I've gone through the text, um, let's say I have 100 rows of text, and each row has 4 or 5 sentences, and I extract these words out of it using key phrase extraction. Now, will I build those 300 or 400 classes, or will I build a standardized classes? What generally will you will see in NLP world is there will be some domain expert who will tell you that these should be the classes, that slow service should be a class, then hygiene should be a class, then timely delivery should be a class. But only if he's a domain expert, he can tell you the standard classes that should be available. But LLMs, going through the text, I will take you through this, but going through the text, going through these key phrases, will themselves figure out the classes, the standardized classes that should be available. And then again, you have the output with the standardized classifications, and then you can select if the classes are enough or not, or do I need to add other classes also and reclassify my text. So this is the standardization part. Again, I'm not saying these tasks are not possible through NLP
Sorry for
or
interrupting. Devan, sorry for interrupting.
yeah,
Please,
go
can
full
you
screen.
please?
Sorry. Okay. So yeah, so I'm not saying these tasks cannot be done by NLP. There are very good NLP models which do all of these tasks, but they can do only one task at a time or two tasks at a time. And you need separate models to be built again, to be tested again, to be fine tuned again with the help of a domain expert. So every time I want to do a new classification, every time I want to do a new semantics application or build a new sentiment analysis model or bot, I need to build the entire pipeline again. But that entire thing can be taken care by LLM. So LLM can provide you standardized labels, and using those labels you can basically classify your entire text without really intervention from an expert. Again, I mean, expert will can basically give a feedback on that, but that is a separate part. The final part, the structured representation, that is what I was talking about with the tool calling in the models. So some models give you this option. I think OpenAI as itself has a inbuilt tool model to it. So if you ask to give the output in JSON, it will give you the output in JSON. But most of the models on the open source side have recently started to shift or tend towards these structured models, structured JSON. So earlier there were none, and we were on an industry level we were really stuck because I cannot use an LLM to generate 2 plus 3 because LLM will say, oh, you are asking for 2 plus 3. I believe 2 plus 3 should be 5. I don't care about that entire text. I care only about the number. So one possibility is I build an NLP task on top of this output, or other, which is currently the case. I build a structured JSON which gives me a structured JSON output. Again, based on the model that you are using, it may or may not be, I mean, 100% adhered to. So sometimes even if you do a tool call for a model which allows a tool call, sometimes you get a text response. But I mean, it is reducing with time, and over I say I believe over the next year we'll have better structured JSON output tool callings. So this way, you can convert NLP tasks into classification tasks, and those classification tasks you can basically now, since you have converted your entire text into a, you can do many things with it. You can do a clustering. You can do a you can tell which
Mm. We cannot hear you, Devanjan. Uh, uh,
is my voice
yes,
better now?
now it is clear. Now it is audible.
Uh, where did I lose everyone? Can someone tell? I'll quickly take from there. Last 2 minutes. Okay. So yeah, I was talking about the comparison between these tasks on an NLP side versus the LLM side. So LLM side, you can do all these tasks with the same model with different tool calls within the same day or within a day or two. But if you want to do all these tasks with the help of NLP, it might take you a month to uh, build a very fine-tuned NLP models for doing these tasks. So that is the power of LLM that I was talking about. The final thing is this JSON, which is really very useful for from industrial perspective, because sometimes, most of the times, we don't want our output to look like a number, because to look like a text, because we cannot do a lot of things with text. We can do a lot of things with numbers, around machine learning or around clustering. We can do a lot of things with if I have number instead of text. So uh, that is the idea there. Yeah. Now I will jump to the application of this. Uh, if anyone has any question, you can ask. Okay, then I will start. Okay, so yes, here I've installed Olama on Google Colab. You can do it on Google Colab also. You can do it locally also. At this point, I'm running Olama at this uh, point, where I'm installing Pandas, Kaggle Hub, Olama as a Python library, Matplotlib, and word cloud. Uh, then I have, for the demonstration purpose, I have taken this Yelp restaurant reviews as my starting point. So I mean, again, it's entirely up to you guys. You guys can have your own data set to try this method on. But basically, the idea is, I will see if I, yeah. So for the input, I have sentiment analysis. Yes, this is, I think, one of the future scopes for sentiment analysis using LLM models, what we are currently going to discuss. Yeah. So this is my data. This up till column D is what I had as an input. So yeah, let's just forget about these things. I will cover it when we go ahead. Okay, so this is my input, right? You have the Yelp URL, which basically tells you the restaurant name, the rating from the customer, the date, and the review text. So this is the kind of thing which you will get in industrial applications also. Let's say if you're doing some sentiment analysis on top of truck data. So what generally happens is, you must have seen, if you go to a mechanic in a dealer showroom, right? If you go to a dealer showroom, the mechanic fills up a job card, which is basically what he's going to do in your vehicle when he's doing the let's say the servicing. And most of the times it generally doesn't happen here, but many a times in I mean, outside, they basically write a comment also. Here also, they have started doing this in companies like truck industry. Generally, ask for these things, where the mechanic is asked to write what they have done. So all of it is text. Now, if you want to do any analysis, for example, if I want to do an analysis on which part is failing most in, let's say, in MP, or which engine component is the one which is having most number of failures in Rajasthan. I cannot go around this text, read every line, and then find out which part is the one which is the culprit. I need to have certain analytics built on top of this text. So the general method was to basically build NLP models again on top of this, which takes its own sweet time and months maybe to build any analytics or to get any value out of this text data. But now we have LLM models which can do that task very quickly. So, are you able to understand the input data? Because this is very critical. After this, we'll not be jumping back to the input data. We'll be looking at the different stages of output. And I wanted to cover the input data very, I mean, in a good way. So, okay, yeah. Then I think we'll jump to the tool again. Sorry, the application again. Right. Okay. So yes, at this point, I have loaded my data and limiting rows. I will cover this late. Collation again, I will cover after some time. Limiting rows is basically this data has around 2000 rows of data. I didn't want to run it on all the 2000 rows of text. I only wanted to run it on 50 rows. So this parameter basically takes care of that. Collation, I will come after some time. I will cover that. And this is my first analysis. So this analysis doesn't this is a Yelp review, right? So it is talking about dishes and restaurants. So this review or this analysis doesn't include dishes separately. So what you will get as an output is I will cover in some time, but yeah. So this is my prompt. Again, you must have heard about the prompt engineering. You must have seen ads, but this is all about prompts. Prompt is no magic. Prompts is it is very iterative process. It requires a domain expertise, and it cannot be done very easily. But again, it is just text. It is nothing else. So it's not a rocket science. You can basically write a good prompt on your own if you have a good domain expertise, or you can ask ChatGPT or other models to write a good prompt for you also. So in this case, this is my prompt: extract sentiment and rating points from the following restaurant review. Return adjacent. So this is where I'm telling the model to return adjacent. But even if I tell the model to return adjacent, it may or may not return adjacent. That part is covered in these tools here. Okay. So what does the JSON contains? So the return a JSON with these keys: ratings, pain points, and positive points. So if there are positive points to a review, and if there are negative points, sometimes the customer write both the things to, I mean, this was good, but this was bad, something like that. So extract the rating, extract the pain points, and extract the positive points. Rating, because I wanted to compare the rating which the customer has given. Let's say the customer has given a 3 with the text. Then the 3 will correlate with the text also, right? So now if I ask the LLM to generate a rating for me, if that rating is similar to the rating given by the customer, then at least I'm in the right track. That LLM is able to get the entire sentiment of the text. So that's why I'm generating the rating also. But again, if you just give this prompt along with the review, it will not be done. You have to call for the tools also. So Olama allows you to give a tool like this. I mean, different architectures or different frameworks other than Olama have different way of tool calling, or agentic as I mean, as nowadays it is called. You can call it agentic. You can, I mean, it is very similar to agent. They are very close to agent. This is not agentic, but we are very close to agentic. This is simple tool calling only. So the tools, what we are giving as a tool to the LLM model is a function. Now this function, the name of function, so you can write this entire thing as a Python function, but the LLM may or may not be able to understand it. So this is how we give it. You give a function, you first tell it's a function, and then you give the description of the function. So the name, extract, review, analysis, a basic description, just like how you give inside a function. a good production ready function, you always write a doc string to it, right? So this is that doc string, and the parameters, the input parameters to the function. So the type will be an object, and these will be its properties. So rating, pain points, and positive points. So this is what we expect as an output from the JSON, which will be given as an output of this function. And then you have the type data type to the output also. So the rating should be an integer, the pain points should be string, and the positive points should also be a string. And what is always required is rating. So rating is something which the LLM should always give. Okay, so this is a basic tool calling for Olama. Now you can do tool calling across different frameworks as I mentioned, and you can ask ChatGPT to generate a sample tool calling, and then inculcate or use that to build your own tool call for your own specific private application. But this is the basic idea. It basically gives you the boilerplate code to generate your own tool call. Okay. So the output of it will have a response message. Uh, Inside message, you'll have tool calls. Inside tool calls, you'll have function arguments, and you basically extract everything one by one. So the final output, this result will look like a JSON. If it is not a JSON, then you return an empty JSON basically, or you do a try exception handling. You always do a try exception handling in production code. If it is not coming out as if there's any error in this code, let's say Olama is not running, or let's say Olama is corrupted for any n reason, then you result then you with exception you generate a basic string, sorry, a basic JSON, and return that as an output. Okay, so I have run this. This is the function. It accepts review text. Review text will be 3 or 4 sentences, every row of data basically, right? So I've done this. As I mentioned, I am doing it on 50 rows. So I'm generating the review and response. Review is basically your result, which is the text part which LLM gives. So I will we'll look at that, and response is the final output basically of the text, which is JSON, which should be JSON, and then you append everything and make a list out of it. So this is what we have done here, right? This tells you have completed how many, I mean, just to track. Okay, so review total, which is the your final output, right? So this is how it looks like. You have pain points available, you have positive points, you have the rating available. So as I mentioned, since you have done a tool calling, we are getting the output. No, yeah, we are getting the output as JSON. Now this is something which we can use for further fine tuning or for further analysis, right? So for each for each row of text, I have one JSON available with me. This is the next line. So let's just see the first line itself. All I can say is that they have a very good ice cream. I would sure recommend for their cookies and creamy ice cream. It is very good. Okay, so this is somehow, or this is how the JSON should look like. So there are no pain points, correct, right? The ice cream is very good. Recommend cookies and cream ice cream. So, and the rating is 5. What is the rating here? Yeah, rating is 5. The actual customer rating is also 5. Okay. So this matches. I mean, you can have a validation sort of thing built on top of this. Okay. Yeah, so this is the basic output. You can see across multiple rows and see if it is actually matching or not. But again, now you must have realized that the positive points have dishes in it also. So I cannot generalize it. I cannot build if I want to build classes, I cannot build a separate class for cookies and a separate class for creme ice cream, right? So because it will not be available across different restaurants. So The other thing I can do is separate out the dishes from the positive and negative points. Positive and negative points are more general in nature. So, good service, bad service, good hygiene, great environment, all those things are general or generic across restaurants. And dishes is somewhat very specific to the restaurant. So, both have their own applications, both have their own positive and negative things. But if I keep it separately, and at the end, if I tell, let's say there are 100 reviews for one restaurant, I can tell the generic points also that you have a good service, you have a fast service, but you have a bad hygiene environment. I can tell that also, which are generic in nature, which can be done across the hotel industry or restaurant industry. And I can tell the specific points also that your this ice cream is very good, your this dish is very bad based on the reviews. So I can do that also. So this sort of thing is done now. Sentiment analysis is done by Google also on a very large scale. So if you open a restaurant, it will give you a basic idea on top telling it's a good environment. Recommended dishes are these. So that sort of thing is also built on this these text sentiment analysis, right? And this is the LLM response. So I will urge everyone to go through this. But yeah, so this is just no, these are all the rows, right? Yeah. So this is the chat response is basically a method of Olama. This is Olama specific. Inside you have all the details around the generation. So you have the model created, time, reason to stop, total duration, all these things are available. The eval count, how much total tokens it has used. It kind of gives you an idea around it. Then you have the message, what Olama's message is as an assistant. You have the content, as I mentioned, thinking model. So this is what Olama is thinking, sorry, Coin 3 is thinking on its own. So these are all thinking. Somewhere you will see think with a forward slash. That's where the thinking of the model stops. Coin 3 model stops. Should be somewhere here. Yeah, here. So this is where the model has stopped thinking about the text. Now it is ready with a response. So thinking is done. Then you have the tool call, and inside tool call you have the function. As I mentioned, we are writing a function inside the tool call. You have the name of the function, the arguments, which is basically your output, and in the output you have all these things. So basically, at the end, we are extracting this part out as our required output from this entire thing. You can keep this entire thinking also for doing validation. So in this happens in RAG applications. I have not used a RAG application because it is very common. But the most important thing in RAG applications from industry perspective is how are you going to validate the response of your LLM? So this is something I believe everyone should go through. If you are telling if you are working on GenAI or RAG, nobody will ask you around RAG how you are generating the response of the RAG. Everyone will ask you how you are validating the response that you are getting from the LLM. So this will help you there. I'm not covering the validation of RAG, how it is run, but please have a look at that. Right. So this is the next response for the next row of data. I mean, again, text intensive. I'll not go through it. I've saved it and it is available. I'll share this entire repo with everyone so everyone can go through it. But yeah, it is same thing. Now I want to keep the dishes separately. So when I say I want to keep the dishes separately, I have to mention it in a prompt also and in the tool also. So again, in the prompt, rating is there, pain points is there, but I have updated the pain points. List of non-dishes issues. So it should not have dishes name in it. And given an example, so slow service, dirty table, positive points again, non-dishes praises like quick service, friendly staff, and pain point dishes and pain positive point dishes. So now it will classify and keep the dishes separately and the generic pain points separately. Uh, I hope you are able to grasp how easy it is to build these final output. I'll show you the output, but I want you to understand the power of this LLM. So if I had to do the same thing using an NLP, uh, again, I mean, it would have been a nightmare for the NLP task to build it again from ground zero and uh, do everything and separate out. How do you separate out dishes? You have to give certain example of dishes. This can be the name of dish. Match if this name is available or something with the same semantics. Vector embeddings is available or not. Here, nothing is required. You just tell because LLM already has it's trained on so much data. It has the understanding of so much things that it will on its own be able to separate out the dishes most of the time. Yeah. So this is the prompt. The prompt ends here where I have attached the review to it from the rows of data. Right here is the review, and then I attach the review. Then the tool call. So in the tool call, I have attached again just two more things: positive dishes, yeah, pinpoint positive dishes and positive point dishes. So just to add it separately, right? And the rest of the thing is similar. And again, I run it through 50 rows of data to see the output now. So yeah, as you can see now, right, you have positive point dishes, ice cream, cookies, and cream ice cream. We read the text. This is what it should have been. Positive points it has not mentioned because there is no generic restaurant related phrase that was there in the sentence. It was only about the dishes. So the positive point is also empty. This is very good because at least let's say if I'm only telling about that restaurant and I can tell, okay, your dishes are well, but nobody said anything about your services or your ambience or your environment, anything, right? So that in itself is a very, very big insight to the restaurant that I need to work on these tasks. My dishes are good, but I need to work on other things also, right? Same way here. Sometimes this thing will happen that you have some sarcasm, and if you don't have enough context, it might go the other way. That you have to be careful around, and that's why you need to build certain validations on top of it. But I mean, it generally you will not see something like that here. Should not. I'll give one example where I've seen it. It should be here. Yeah. So you see this part, the last one. So this is pain point dishes is Bobas. Pain points: kitchen area not clean, kitchen area not stocked, staff not polite, staff annoyed, general surface improvement. Right now, in the positive points also there's polite staff. So there must be something going on here in the text which the LLM is not able to uh, take out of context. So I'm not just sorry, I'm not just showing where it is working well, but I'll also share where it's not. So let's take the 50th, the last row. Yeah, this one. One of the staff members was polite and another was expressive in a non-polite way. So you have a polite staff also and a non-polite staff also. And the LLM has put both. You see what how much text sometimes it's written, right? It's no into it. How will you extract all things? But yeah. So you get the idea. It's not foolproof. Again, you have to build certain validations. If you are doing it on production thing, you will always have validation. So whatever you generate as an output from GenAI, always think about validation part. If you have not seen, you must have not seen few of the things around the validation, and then I would recommend everyone to go through the validation, how the LLM response is validated. So I'll not cover that here, but yeah. Okay, again the same thing, the response, the thinking, tool call, everything, same thing here. So this way, what we have now is this JSON file, this nice JSON file. But yeah, now comes the next part, which is extracting the standard names out of these JSONs. So I've saved the JSON response at this point, and in the CSV also for stage verification or stage validations of the output. Yeah. Now we are combining and standardizing the positive and negative reviews. So I can say slow service or the service was slow, but ideally I should have only one label, slow service, and it should correspond to both. That that is the idea here, standardization, right? So again, I'm using LLM for this and with the tool call. So this is my prompt. You are a smart assistant helping normalize restaurant feedback. Here is the current mapping. So let's say the LLM at one point is, if I've given 50 different labels to it, service not well, service was not okay, like this I've given 50 labels, right? I've asked it to generate only 5 or 10 labels. But uh, if if there are thousand such reviews or thousand such labels, I am asking it to refer to all those thousand at the same time for the next label generation. You're getting the idea, right? It's a many to many sort of mapping. So that's why uh, what 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 I've done here is I've taken only 10 reviews at a time, generate the labels or generate the standard labels from those 10. Let's say there are only 3 or 4 labels, then take the next 10 labels and see if those new 10 labels can be fit to any of the standard labels which were generated previously. If not, then only add a new standard label to it. So that way, you're not loading the LLM with lot of standard labels and the new incoming labels. So that is a basic turnaround on top of this. The reason I've done this is because even Coin 3 after 200 labels or something was failing because of context overload. So this is a sort of a bypass method around it to help it keep the standardized labels in check. So these are the things which you can do in software engineering even now, right? It's not entirely that you have a LLM and LLM will solve everything for you. You have to have your decision-making ability and see why things are not working and make a way around it. Okay, so again, the prompt is taken from here, and then you have the tool call. Then here the function basically is standardized feedback points. So you are standardizing everything, and then you are mapping all the input labels to a standard label. So the input will have all the labels which are available earlier, and the output or the value of the key value pair, the value will have standardized labels to it. Then you do the tool call, get the response, extract the content out of it, and this is how it looks like. So yeah, so nice little local place, local establishment, accommodating policies, allowed early ordering, accommodation policies. I mean, it has kept it inside accommodating policies only. So you see now you're reducing the number of labels, which is very important to draw any insights out of the data, because you cannot have thousand labels meaning the same thing, right? So this is how you can reduce the number of labels. Convenient parking, excellent service here also, efficient service, excellent service, everything comes under excellent service, right? Better service is also coming under excellent service, because excellent service is something which the LLM must have seen earlier. So everything is being linked to excellent service, right? So this way you are standardizing the positive feedbacks, and this is where you are standardizing the negative feedbacks. So uh, this is the overall idea here. We have reduced the number of labels. First, we have extracted the labels, made a JSON. Now we have reduced the number of labels by standardizing the labels, and now we are reassigning those labels back to the text itself. So these are the reduced labels. We have attached these labels back to the original text. So the final output, I will show the final output how it looks like. Yeah, this is the one itself. So yeah. So for each row, you have ratings, review, and I've also attached the original review itself here. But that is just for a validation purpose, because validation is something which you always do. You have the pain points and everything, positive dishes, all those things are available for each row of data. Now I can do a group by on the restaurant name and tell for a specific restaurant for a specific time period also that for this time period you had a great service. These were your good dishes, these were your bad dishes, this was not working well for your restaurant for this time period. All those sort of analytics now you can think of, right? All those things now you can do. Same thing is applicable with what I mentioned earlier, a maintenance task or something like that. These for example, uh, an engine part was failing in this time period in this summer. This part of the exhaust was failing. These sort of insights are very important or very critical for an organization because it helps them to keep their supply chain intact and provide a enormous value actually, because this sort of thing was not really possible earlier. It was probabilistic earlier also, it is probabilistic here also, but at least now we have a better understanding of the probabilities, and the probabilistic model is also much better because we are not focused on the I should say the expertise of a single man who must have worked on NLP and who is good with the domain also. We are more independent in our execution, in our understanding of the reviews or text. So this is the idea here. This is all the things that you can do with it now. So you have the JSON with you available. You can reduce it and see how many labels are currently available. So let's say local establishment, a nice little local place supporting local business. Then you have accommodate. I've reversed it. Basically, I've from values to keys, I have reversed it now just to showcase what grouping it has done. So excellent service, great service, better service, fast service, friendly and efficient service, efficient, excellent. All these mean the same thing. But if you had applied a vector embedding or a semantic embedding on top of it, it would have taken forever for everyone. So this is the idea here. Now you can do a WordPress word cloud on top of it for your specific restaurant and tell the way word cloud works is it makes a few letters bolder which have a higher frequency, and the one which has lower frequency becomes smaller. So you can build a word cloud for your specific restaurant and send it across to them. That is a good insight. So this is the first industrial task application that I wanted to cover. Any questions at this point? No questions. Should we go on? Okay. Yeah. So up to this. Okay. The final task for me is this one: document generation and the code flow generation for code base. I will give a quick summary around this. I have already given, but explain how it is doing everything. This is the one where I've used Docker just to showcase you guys how Docker is actually implemented and used on the industry level. And the output finally it makes these two thinking files and explain files. I will show how that is also done. A quick walk through the code and Docker and virtual environment, everything on this. Okay. Okay. So first off, the README file. I'll share this GitHub repo with everyone, so you guys can also go through this later on. But we'll quickly go through the GitHub repo. Uh, we create a virtual environment, install the dependencies. So in dependencies, there's only one request as of now. Then Then you do a ch mode of this sh file. I'll go through the sh file. What this sh file does is basically start the dockers and containers. So there are multiple dockers and docker files and containers interacting with each other. So this instantiates those dockers, keeps everything ready. This is at till this point is where data engineering team will support you. They will whenever you provide a docker, you can provide a docker image to the data engineering team. They will instantiate it, keep it ready for whenever your api request comes. So at this point is where the data engineering part ends. And then you have the you check the validate if it is deployed properly, check if the API response is coming properly, and then do your build your see if your application is working properly or not, or integrate the application into your own application from the API. Okay, so yeah, start file. This file basically sees if you have GPU available locally or not. So it checks if the GPU is available by NVIDIA SMI. If GPU is available, then it builds a GPU build. If the GPU is not available, then it does a CPU build. So these are the Docker Compose files. Docker Compose file basically instantiates multiple Dockers with certain OS service as service. So um, these are the two services that currently I'm running. So both of these will be separate containers talking to each other in the same environment. So that is why Docker Compose is useful. So I don't want this Olama container to directly interact with app container. There might be a possibility that the app container has certain Python dependencies which uh, which overacts or which counters against the Olama dependencies. So I want to keep them in separate containers. It might be a possibility that Olama container is what I want to use. I don't want to use app for my other applications. Then I should not integrate both of them together in the same Docker. I should keep them separate in the same container. I should keep them in separate containers and let them talk to each other if it is required. And how they talk to each other with these networks. So this is how you basically make a containerized environment where there are multiple containers talking to each other internally. Again, this entire thing is completely excluded or completely isolated from the outside world. The only way it is talking to the outside world currently, it is not currently talking, but the only way it is talking to each other currently is with these ports 8081 and 5000, right? This port is inside the container of Olama container, and this is the inside port of the app container, and this is the exposed container. So exposed port of this container. So if I want this application to talk to this application, I will talk with 5000 to 8081. This is the overall idea. Again, CPU Docker Compose is different. If your OS doesn't have GPU capabilities, or sorry, if your system doesn't have GPU capabilities, and GPU is different. So Both of them are slightly different. The reason is Olama offers a GPU build also. So if you have GPU, it is much faster. And I mean, why not use the GPU resources if they are already available, right? So this is how you can build a GPU based containerized environment also. So based on what is available, it instantiates and builds your containers. This once again. This is how it looks like. So this is the containerized environment. Inside this, you have app container and Olama service. So these two containers, they are talking to each other inside this use case development environment. Both of these containers. Okay. Then you check if the containers are running properly, if their health is good. Then you pull the Qwen3 model into the Olama service. This one, Olama container, and the Qwen3 model, you pull it, and you can tell if it is pulled correctly or not by checking the list of models which are available once the this pull is Olama pull Qwen3 is done. And if it is successful, it returns it is successful and ready for use. Otherwise, it gives an error. So this is the idea how let's say the data engineering team will build Olama containers or this both these containers and provide you via an API to talk to these containers. Okay. Yeah. Then I will cover both these containers. What all goes inside these containers now. So this is Olama base. Olama base basically context tell you which directory to look into. So it will look inside this Olama base directory where you have another Docker file. This Docker file is nothing but just the Olama image from Olama latest. So it, as I mentioned, there's a Docker Hub, right? So Docker Hub has the official Olama image available, and I always want the latest image. I can select a image version also, but currently I want the latest image. That is all there is inside this Olama base. The other, yeah, this other one is app. So context is app, so it will look inside this app directory and should find the Docker file. So the Docker file is available. This is the Docker file. This is much more complex, but again, the idea is similar. You use a base OS image. This is the guest OS image from our discussion on the PPT, right? Then some set certain environment variables for I mean keeping the time and everything. Then you install a version of Python. So I installed Python 3.11 Slim. Slim has very less number of Python dependencies pre-installed. That's why we always use Slim. I mean, it depends on your use case, but yeah. Then you have the working directory inside the container. So inside the container, this is if you enter the container, this is sorry. So if you enter the container, this is always where you will start. Yeah, so these are the OS dependencies, the Linux dependencies that I want to install. For example, curl to talk to a HTTP page, I need curl. Sudo is basically to have a sudo command to overwrite any user, basically admin sort of thing. And I mean, all these are OS dependencies to run the below code or below application. Then you copy the requirement.txt file. So this requirement.txt file, because it is inside app, will be copied, and it will be copied inside slash app because slash app is my working directory. Now I have copied the requirement.txt and I have installed the requirement.txt, and I'm also copying anything which is inside the app. So these three things are there: app.py, dockerfile, and requirement.txt, and copying it as it is inside slash app in the container. And then I'm exposing a Flask port to talk to the outside world. Basically, outside world for this container will be the other container which is there. Because Flask needs a port to talk to other applications, or the API needs a port to talk to other um, applications. And then I'm running this Python app.py. So app.py is nothing but a Flask API file, and it keeps on running. It is always in the running. That's why it is simply written as CMD, basically a CLI command of Python app.py. So it will start the Python app.py application, basically app. Again, I will not go through the details of this. You can go through it on your own. But basically, the idea here is I built a basic home just to do a validation if this container is working well or not. Then to get the response from Olama. So Olama is located inside a different container, right? And I can restart using 11434, and then this is basically the standard API provided by Olama, which I can use. So I'm just using that, and with this API you also need the model which you want to run. So this is basically the official API for Olama which I'm using at this point. With this API you need the payload which should have the model, the prompt, and should I stream the response or not. So ChatGPT, when you enter something, it streams, right? It gives one word at a time. I don't want that. I want the entire response at one go, right? So I'm sending this payload to this URL via response, and expecting if it is able to send it or not. So uh, I'm sending this as JSON, and response. This is how I do the return part. If it is not working, then I should get an error. Same way, so this part basically takes care of talking to the Olama container, right? Now I can integrate this function with all my functions. If I only want to talk to the Olama, I can only use this to talk. Or if I want to do something on top of it, which, for example, currently we are building a MD file or a explanation file of the code using Olama. So I'm building an application on top of it. Otherwise, I can expose directly the Olama container to the outside world also. But here we are doing the MD file or the description file generation, right? Using this, and this is the thinking, the MD content, and the complete response. Again, you have think. This is written to extract only the thinking part and the complete response as separate. Keep it separate. You can also directly, as I mentioned, directly talk to Olama. You don't need to always have the MD file generation. I just want to talk to Olama regarding some other applications. I can do that using /ask method. Again, it's a post. Most of the things that I worked on are posts. I mean, very rarely we do something else. Sorry, ask is where I've used this one, and query is where I want to ask general things. I can do that with the Olama uh, Queen3 model. This is the overall idea around the app, right? And this is the overall explanation of the code base. You can go through it on your own. This is the idea, right? I will show you the sample output, how it looks like. Okay, so let's say I'm not very comfortable understanding the PyProject TOML files. These are I've taken one sample repo. This repo is light blue. You may have heard about this, but it's basically using computer vision a lot for uh, finding the similarities between two images, right? So light blue is one of those methods which helps you do that. Yeah. So it has this PyProject.toml file. Now, I am really not familiar. If I'm not really familiar with toml file, I can go to the explain part for this. This is the explain part, and I can do a preview of it. Yeah. So it gives you a good quick preview of this TOML file. It tells you how it is working, what it is useful for, what it does, by light blue, I mean, all those things. It review file project, explain file project. Yeah. So it gives you a quick summary, everything. I mean, these are the things which you want, or which is expected of development engineers to build. But if let's say these are not there, you can directly copy paste these things as a regional file in the regional file and go about it. Or if I want to understand, I can read this along with the file itself. Open them side by side and read around it. So this is the idea. Let's take another example. All these files are Python files. We have okay. So this is the SVG image, SVG thing, right? And it has given an explanation of that also. So do a visualization, Control Shift V, right? And let's take another Python file from the view. Right. So this has many lines. It's almost 750 lines of code, 700 lines of code, and it has the explain file also. And thinking is basically what the LLM was thinking while writing the markdown file, the explanation file. So I mean, you can have a, this is basically used for doing the validation, but this is the output file, the useful file. And if I do a preview of this, this is how it looks like. Uh, it is a complete model architecture. So this is something what we call as code to architecture. If I want to draw a diagram, if I get a new repo, I want to see what the repo is doing, we basically go the other way from code to architecture. So this can help you with the code to architecture thing. So model architecture overview, main components, the key implementation details, issues and fixes, everything is there in the code. Um, Recommendations are also there. I mean, it's just not reading the file to explain it, but also suggesting few changes if you want to do. So let's say if you find something which really pops out, which shouldn't have been there, but which is there, it will tell you and it will suggest something to you to change it also. Again, it entirely depends on the kind of prompt you are writing to get this response. Um, Different prompts in the production code are different. I mean, I have not gone through those, but there are codes which can even give you the graphic presentation also. So it depends on the kind of prompt that you're writing for these elements. They are very powerful. Yeah, this is the basic idea around this. The way we run this thing is, I think I've already covered, but I'll share again. Yeah, so the way we run it is we simply run mdcreation.py. What it does internally is it talks to the Flask API, the query one. Yeah, the query one. The query API talks to the query API, and as an input, we give the directories which are for which you want the output for. You can give directory, in the directory, you can also just write a single file if you want the output for a single file. And there are optional other arguments also. For example, you can ignore the git ignore files, you can ignore the pycache or .git files, directories. And you can also tell if you want the thinking file or not. So for example, for the production code, I don't want a thinking file, I only want the explain file. So you can do that also. The output file, again, I've already covered this. But let's say if I only want to talk to Queen3 model, because I'm building a separate application which I will deploy in the same container environment, then I can do that also using this API. So I can use this API inside my own application and build it. So this is generally how the data engineering team will tell you that this is your API, build your application around it, and then give me the Dockerize or the image of your application, and we will see if it talks to the API. If it does, then we'll deploy your application. So this is the overall idea around it. Yeah. So any questions? I've covered my part. Any questions? Anyone? Okay. Certainly, sir, I have covered the both the applications and the entirety of um, roadmap that I wanted to cover for this presentation.
Thank you, sir.
Okay, thank you. Thank you, Devanjan, for this session. I hope some of the important topics like what is Docker and Kubernetes, I mean, audience might have uh, understood some of the things from this session and two case studies and the examples that you've shown. I hope they understood. And meanwhile, if you can share, so one of the comment was there to share some supporting document to read about it. So if you
Yes.
can share this slide and any other material, that will.
Yes, I will share the slide, the code walkthrough, sorry, the documentation around the learning Docker
Sure.
and both these repos which we have gone through.
Okay. Okay. Thank you. Thank you so much for joining us. And
Thank you, everyone. Have a great day.
thank you. Okay. So we will have a 15-minute break, and exactly 4 p.m. We will have a validatory session. So it will not a formal lecture session. It will be a just an interaction and feedback and validity session final. So